we're going to start by working out the angle sum rule for sine, and then we're going to derive the other relationships from that one. To begin, we draw two right-angled triangles. The hypotenuse of one becomes one of the other sides for the second. And we label the free hypotenuse of the second triangle to be 1 unit. The inner angle on the first triangle is x, and the inner angle on the second triangle is y. Now, if we have a look here, this angle is x, so is this one. And if this is 90, then this must be 90 minus x. So in this triangle, this must be x. Comfortable with that? Then we're nearly there. Let's have a look. I'm interested in this angle here, x plus y. Well, if the hypotenuse is 1, then the sine of x plus y is equal to this total length, BF, over 1. But what's this total length here? Well, it's got two parts. First, we want to work out this one. We're going to go from here. If this is 1 and this angle's y, and that's a right angle, then this must be sine y. If that's sine y, and this angle, remember, is x, then this length must be sine y times cos x, adjacent to x. So this height, BE, is sine y cos x. What about this part, from E to F? Well, if that's 1 and that's y, this length here must be cos y. If that's cos y, and that's x, then this length must be cos y opposite x, so cos y times sine x. So EF is cos y sine x. And BF is cos x sine y plus cos y sine x. And that's sine x plus y. Okay, so hopefully I've now managed to convince you that the sine of x plus y is sine x cos y plus cos x sine y. Where to from here? Well, that's the angle sum rule. I can very easily get to the angle difference rule, because that's just sine of x plus negative y, which means it's this with a negative. Sine x cos negative y plus cos x sine negative y. But cos of negative y is the same as cos of y. How can I convince you of that? Think about what cos does. Cos this way is the same as cos that way. Cos of negative y is the same as cos y, because we're talking about the x coordinate. So that's sine x cos y. Now what about this one? Sine of negative y. So now we're looking, I'll get a different colour. Now we're looking here and here. No, that's confusing. Let me explain it a different way. Cos of y and negative y are the same because they're the x coordinate, but sine is the y coordinate. So sine of negative y down here is negative of sine of y. So that makes it minus cos x sine y. So that's the angle sum, and that's the angle difference for sine. But how am I going to get to cos? Well, cos of an angle is the sine of 90 minus it, and vice versa. Instead of 90, we're actually going to use pi on 2 because we like radians now. So let me go like this. But cos of an angle is sine of pi on 2 minus the angle. And sine of an angle is cos of pi on 2 minus the angle. Now, if you're not sure about that, go back and look at those graphs again. Assuming you believe this, then cos of x plus y is sine of pi on 2 minus x plus y. That's just applying this. Now I'm going to rearrange this before I plug it in here. It's sine of pi on 2 minus x minus y. I'm then going to apply the angle difference rule with sine. So this is sine of pi on 2 minus x cos y minus cos pi on 2 minus x sine y. But this is the same as cos. Cos x cos y minus this is the same as sine. Sine x sine y. And there's my rule for the angle sum for cos. With apologies for the noise of my barking dog in the background. So then it's very easy, same way we did before, to get the angle difference. X minus y is just going to be here. It's cos x cos negative y. Oh, I skipped this step. Hopefully you can make sense of it without that. Minus sine x sine minus y. But cos minus y is just cos y. Sine negative y is negative sine y. So this sign changed. And there's my cos for angle difference rule.